We looked at how using the joint PMF of x and y, we can find the conditional PMF of x given y is equal to small y, or we can also find the conditional PMF of y given x is equal to small x. Now we want to learn how using the conditional PMF, we can find conditional expectations and variances. Now, firstly, we look at how we can find the expected value of x given y is equal to small y. So we're finding the expectation of our discrete random variable x conditioned on the observation of another variable capital Y, where the observation is small y. And this is found as summation over all x times probability x is equal to x given y is equal to small y. So this is very similar to the formula that we had for expectation of a discrete random variable x. That used to be expected value of x is summation over all x probability x is equal to small x. Here the only difference is that now because we want conditional expectation, the expectation of x conditioned on the observation of y, so we'll use the conditional PMF of x rather than the marginal PMF of x. That's the only difference. Similar to how we find expected value of x, we can also find expected value of any function of x conditioned on the observation of y. Here instead of x, you just have g of x. Again, this is very similar to how we find expected value of a function of a discrete random variable. The only difference being now instead of the marginal PMF, instead of probability x is equal to small x, we're using the conditional PMF, where we're conditioning on the observation of y. And the formula for variance is also very similar, where now we can find the variance of x given y is equal to small y as just expected value of x square given y small y minus expected value of x given y is equal to y whole square. So using the conditional PMF, we can find conditional expectation and variance. And these are the same formulas that we had before for discrete random variables when you were finding expected value of x, expected value of g of x, variance of x. The only difference is that now instead of the marginal PMF, we're using the conditional PMFs, where we're conditioning on the observation of y. Okay, so let's continue with the same example. We were looking at an earlier example. We're using a joint PMF of x and y. We found the conditional PMF of x given y is equal to 1 as follows. So we found the probability x is equal to 0 and x is equal to 1 given y is equal to 1. This gave us the conditional PMF of x given y is equal to 1. So the example that we were looking at, let's just quickly look over here. So this was the example that we were looking at. We were given the joint PMF of x and y, and from here we found the conditional PMF of x given y is equal to 1. And for this, we found the probability that x is equal to each of its values given y is equal to 1. That was the conditional PMF of x given y is equal to 1. Right, so this is the conditional PMF we found here. Now let's use this conditional PMF to first find expected value of x given y is equal to 1. So we know this is just simply going to be, we have its conditional PMF, which is going to do summation over all x probability x is equal to x given y is equal to 1. So if we go back to the formulas that we learned, so we want to find expected value of x given y is equal to 1. So the observation which we're conditioning is small y is 1. So this will just be summation over all x probability x is equal to x given y is equal to 1. So how will we go about finding it? So we'll make an additional column of x times probability x is x given y is 1. So this will be just 0 into 1 by 3, 0, 1 into 2 by 3 is 2 by 3. And then we just sum this up and this turns out to be 2 by 3. So expected value of x given y is equal to 1 is just summation over all x times probability x is equal to x given y is equal to 1. So this is essentially the expected value of x conditioned on the observation, conditioned on the fact that y is equal to 1, right? So it's expected value of x given y is equal to 1. So we're finding the expected value of x conditioned on the observation of another random variable y, and that observation in this case is 1. We can similarly find expected value of x squared given y is equal to 1. So here we're going to apply this formula. Expected value g of x given y is equal to y is equal to this. Here g of x is equal to x squared. So expected value of x squared given y is equal to 1 is just summation over all x squared, probability x is x given y is 1. Here again, the observation on which we're conditioning is y is equal to 1. Right, so this is going to be, so here we make two additional columns. We first have our conditional PMF x and then probability x is x given y is 1. Then we'll make x square, which is 0 square 0, 1 square is 1. And then we'll just make another column x square into probability x is x given y is 1. So this is like 0 into 1 by 3, 0, 1 into 2 by 3 is 2 by 3. And from here we can see what summation x square, probability x is x given y is equal to 1 is. And that's our expected value of x square given y is 1. Now if you want to find variance of x given y is equal to 1. So we know that is expected value of x square given y is 1 minus expected value of x given y is 1 whole square. So this is very similar to how we used to find variance of x. That used to be variance of x is expected value of x square minus expected value of x whole square. The only difference is that now we're finding this variance conditioned on y is equal to 1. So we're using conditional expectations, right, which we found using the conditional PMF. We already found expected value of x square given y is 1 is 2 by 3, and also expected value of x given y is equal to 1 is 2 by 3. So from here, it follows that variance of x given y is equal to 1 is 2 by 9. So in this way, using the conditional PMF, you can find conditional expectations and variance. The formulas are the same that we had when we were finding, expectations and variances for a discrete random variable x. Right, when you're just finding expected value for x, expected value g of x, variance of x, the formulas are the same. The only difference is that now you're going to use the conditional PMFs rather than marginal PMFs, because now you're finding these expectations and variance conditioned on the observation of another random variable.